Our second case occurred on December 16, 2019, and we'll again be focusing on Mississippi. The 20Z convective outlook for this case featured a narrower moderate risk, but with similar probabilities, just lacking the hatched damaging wind outlook here. So in this case, we're going to be focusing first near the northwestern gradient of the moderate to slight risk in northwestern Mississippi. At 12Z the morning of the event, we see a distinct northern stream jet from the upper Midwest through the northeast. Upper level divergence is not quite as intense in this case compared to the previous one, but enhanced upper level and mid-level flow is evident over and upstream of our area of interest. A shortwave trough is analyzed over the central high plains, and that's going to be approaching the area later in the day. Additionally, at this time, we see a baroclinic zone at 850 millibars and near the surface, associated with a surface low over the southern plains area. Dew points in this case around 60s to maybe mid-50s as you get closer to the front itself. And the low-level jet is not quite as strong either in this case compared to the previous, looking at around 30 to 40, maybe 45 knots in some situations. So quite a different setup than what we were dealing with before. Jumping ahead to 0Z though, by which time the event is ongoing. The northern stream jet has notably strengthened. In this case, you have a right entrance region extending over the deep south. Also see some diffluence in 300 millibar flow near the Mississippi River Delta. This region is coincident with a strong divergence, as you see here, with all of the yellow contours there. At 500 millibars, strong flow of 75 to 95 knots was observed near the advancing shortwave trough from Oklahoma northeastward all the way up toward the Great Lakes. The low-level jet here remains steady about 30 to 40 knots as the cold front has shifted southeastward a bit. Dew points in the warm sector remain in the 60s for the most part. You do see some lower 70s as you get closer to the Gulf. So let's step back slightly to the 20 to 23Z time frame and walk through fields relevant to the convective environment. At 20Z, a tight mixed layer cape gradient is evident across northwestern Mississippi in the vicinity of the cold front. This remains the case at 23Z, by which time the overall values of cape in the warm sector have decreased just very slightly. As discussed in a prior module, one common aspect of severe high shear low cape events is that they might originate in a higher cape environment and then move into a lower cape environment, and that may have happened here. Severe high shear low cape convection might also track along sharp analyzed gradients of cape, which appears to be the case in this situation as well. Effective bulk shear magnitudes range from around 50 to 65 knots in the unstable sector, both at 20 and 23Z. As shown in the surface observations, dew points range from the upper 50s across the northern part of the domain through the lower 60s, maybe into the lower 70s as you get really far south in the domain. Surface winds decreased slightly between 20 and 23Z, but overall the changes were not significant. And the baroclinic zone has shifted ever so slightly in this 3-hour period as well, particularly across northern Mississippi and southern Tennessee. Compared to the 850 millibar upper air charts shown earlier, mesoanalysis does suggest some localized enhancement to the low-level jet across northern Mississippi, northwestern Alabama, and into western and middle Tennessee. Through there you see some 50-knot barbs being plotted both at 20 and 23Z. Max theta E difference fields suggest potential instability exists through much of the unstable sector, including nosing into our area of interest here across northern Mississippi. At 20Z, 0 to 3 kilometer shear vectors are out of the southwest, around 40 to 50 knots, and those actually increase to 55 or 60 knots in some locations by 23Z. As in our previous case, bowing segments toward the northeast would be able to take full advantage of this shear in the context of the 3 ingredients method, but really any surge or bow towards the northeast or anywhere within that quadrant would exceed the 30-knot line normal threshold, or at least come pretty close. 0 to 3 kilometer lapse rates in this case were more stable than 7 degrees Celsius per kilometer, so nothing is shaded here at either time. But we do see a localized area of 0 to 3 kilometer cape of 50 to 75 joules per kilogram or greater, first over north central Mississippi, that later extends northeastward through northwestern Alabama. If we're dealing with a QLCS, this corridor would meet the nudger criterion for low-level CAPE. SureB values are quite high throughout most of the warm sector, so we're not going to dwell on that much here. The modified SureB, which was designed to provide a bit finer point on where significant sphere hazards could be expected in these high shear low CAPE environments, really highlights that corridor of northeastern Mississippi and northwestern Alabama that we've been discussing thus far. Again, I'm focusing primarily on values of 4 or higher, which limit the false alarm area in my experience. However, note that given its inclusion of vertical velocities, the modified SureB can also be contaminated by convection as well, which might be ongoing at 23Z in our area of interest here. As we did in the first case, if we consider where enhanced values of the modified SureB overlap with northern nose of enhanced STP values, we're pointed towards northeastern Mississippi and northwestern Alabama. Here, STP values around 1 are present at 20Z. By 23Z, this corridor of enhanced STP values has retreated southwestward slightly, but the axis of higher values continues to extend toward northwestern Alabama. And again, just stepping back, that is where those higher values of the modified SureB overlap with the northern extent of the STP values. All right, let's take a look at some radar data again. All right, so let's dive into this second event here, and we're going to be focused on this portion of convection, or this area of convection, starting near Sumner, Mississippi. And I'm going to zoom out here just to give you a sense of where that is. So northwestern part of Mississippi near the border with Arkansas for now. You can see we're looking at the Columbus AFB radar, which is in far northeastern Mississippi. So overall, not the best area in terms of radar coverage. We're looking at about 13,000 feet above radar level here, but overall you're kind of in no man's land when it comes to radar data. So we're going to stick with this, especially because storms are moving from west to east, so they'll be approaching GWX as we go a little bit farther into the event. But you can see just in general, I mean, you have some embedded stronger convection here. This is the strongest cell that we can identify, at least in this radar imagery, based on reflectivity. A broken line of convection that extends off to the northeast, maybe some individual discrete cells a little bit farther northeast, and hard to see what's going on down to the southwest because you're overshooting a lot of the convection there. But overall, let's take a look at what we're dealing with here near Sumner. And again, this is close to that northwestern edge of the unstable sector in this particular case. So just taking an initial look, one thing that stands out to me is it looks like you have some pretty decent mid-level convergence here at this point. So outbounds, again, this is base velocity like it was in the previous case. Outbounds of around 10 knots or so, and inbounds of 45, 50 knots in some cases. So pretty strong signature there for mid-altitude radial convergence, or maybe a MARC signature in place there near Sumner. This convection does have decent depth to it at the moment, but overall, since we're so far from radar, I mean, it's hard to gauge much more at the current time. As you tilt up there a little bit, maybe even stronger convergence. But nonetheless, let's step forward a few scans and get a sense of how this is evolving with time. So just kind of keeping an eye on things as this convection moves off to the east and northeast. Still pretty strong mid-level convergence there. Couple areas of robust convection, some stronger KDP now beginning to develop to the northwest and to the west of Charleston, Mississippi. As I go through a couple more scans here, you can get the sense that there's a pretty strong rear inflow jet beginning to emerge north of Charleston here. See it a little bit in terms of eroding reflectivity along the backside of the line here. So you have that little notch on the backside of Really starting to see that apparent rear inflow jet now making an appearance. Some pixels inbound velocities there of over 50 knots. And actually starting to see a little bit of reflectivity drop out here as well. I mean, it's maybe not quite as noticeable because it's still fairly strong reflectivity, but you're going from the leading convective line of 50, 60 plus dBz down to around 45 dBz on the back side of that there. So let's go a little bit farther. Yeah, seeing a broader drop in reflectivity now, all along the line to the northeast of Charleston, and that's coincident with where you have those stronger inbounds there as well. Pretty decent KDP core here as well. And actually, if you start to look at KDP a little bit more closely, maybe even a line break there in KDP at this point. If I step back, this area of KDP was a little bit broader, more elliptical in shape a few minutes prior, and you start to see that reflectivity drop, or excuse me, that KDP drop north and northwest of Oakland there around that time. So very interesting. Let's see if I tilt up a little bit, what do we see? If I tilt up a bit here on reflectivity, you actually see that this northern bit of the line is starting to be cut off a little bit in terms of reflectivity, so a distinct drop in reflectivity there south of Cortland. Let's go a little bit farther, and at this point, the inbound velocities really increase across this entire section of the line, and you see a distinct bowing feature here emerging with time too. Just quickly looking at the updraft, downdraft convergence zone, you're very well balanced, maybe even a little bit shear dominant at this point. I have a couple areas of KDP cores, one up near Cortland, one a little bit farther south along the line. But just given what we're seeing here, this may be an appropriate time to do a warning decision. So let's go ahead and do that at this time. In this case, the three ingredients were indeed met, had that balanced updraft, downdraft convergence zone, plenty of line normal 0 to 3 kilometer shear, and a bow or surge in place. Let's go through some of the confidence builders and nudgers here. So we did have that reflectivity drop, consistent with a descending rear inflow jet. Wouldn't necessarily call it an enhanced surge or bow at this time, but I could understand if someone subjectively considered that to be enhancing or pivoting in some way. If we looked farther aloft, we did see that line break, at least in KDP, and it was becoming more apparent in reflectivity as well. So I'll go ahead and throw the line break in there. Didn't really have any of these other features just yet. Didn't have a notable mesovortex at the current time. Didn't have reflectivity tags. Environmentally, there may have been 40 joules per kilogram of 0 to 3 kilometer cape. It's a little bit tough to tell exactly where that was. Whether you toggle it on or off, it doesn't really make a difference in this particular case because none of the other confidence builders or nudgers were met. So either way, we're looking at severe thunderstorm warning with a tornado possible tag as the recommendation here. And I think that's a good call, just subjectively, given where we're at in the evolution of this QLCS. So let's say that we've issued a severe with tornado possible tag and take a look at how the system evolves from here. All right, so we have our severe thunderstorm warning with tornado possible tag again. So like the last time, this last event, I would encourage you to determine when you would issue a tornado warning as we move forward, and I'll kind of talk through my thought process as well. So our warning decision point was right here about 2029 or so UTC. Had pretty decent Boeing signature here, evidence of a rear inflow jet, because we're still looking at 7,000 or 8,000 feet above radar level at this point, but pretty notable descending rear inflow jet as well. Haven't really talked about it yet, but we'll have to keep an eye on this convection that's developing out ahead of this Boeing segment as well. But let's just kind of step through things scan by scan here and see how things evolve. Seeing a little bit better inbound velocities here, a little bit stronger evidence of that rear inflow jet impinging on the leading edge of the line. At this point, I have a really nice KDP core, basically co-located with the strongest reflectivity core as well, and continuing to see that evidence of the rear inflow jet, seeing that feature strengthen and expand a little bit with time, and kind of going back a couple of scans and moving forward to where we are now here near Oakland, or a little bit north of Oakland. Pretty distinct area of decreased reflectivity as well. So at this point, really starting to see that rear inflow jet make its presence known, almost like an arrow pointing towards Water Valley here in terms of the inbound velocities, and really strengthening too. You're looking at about 60 knots in some places, maybe a little bit higher in your stronger pixels. If I tilt up a little bit, you almost see some decreased reflectivity wrapping around to the south side of the stronger reflectivity core here, to the west of Water Valley, so something to keep an eye on. And I've noticed with time, you initially had this really strong area, or notable area, of spectrum width to the northeast of Oakland that was right along the leading edge of the bow. That has shifted with time to be more towards the northern side of the bow, and pretty much coincident with where you have these really strong inbounds next to effectively zero radial relative winds. So there is some pretty clear rotation here northwest of Water Valley that is coincident with enhanced spectrum width. I would really watch this area for potential mesovortex development. And you're really starting to see that a little bit here now. So this might be enough to tip you. This may be enough to tip the scales towards a tornado warning. Continuing on with time, and really just focusing on the lowest tilt here. Of course, you don't want to just look at the lowest tilt when you're in real-time operations, but this far away from radar, this can still be pretty insightful to watch how this evolves. Maybe a little bit of a tighter couplet here, just off to the east of Taylor. And one thing I'll note is you have more of a circular maximum in spectrum width at this point, which sometimes indicates that you have that concentrated area of rotation ongoing at this point. And if I go back a couple of scans, you see it was more of a linear feature, a little bit maybe elliptical feature to the southwest of Taylor, and that's become increasingly circular with time. So if that trend continues, maybe that'll mean there's a tornado ongoing there. But I go forward a couple of scans, and that is seemingly dissipated. Continuing on here, you have this kind of band of convection out ahead of this main line. You have what almost looks like a comma head signature near Oxford, so the Oxford comma, I suppose. But pretty clear area of decreased reflectivity as well to the southeast of Oxford. And if you look from east of Taylor down towards Water Valley, very broad area of strong inbound velocities all throughout this area. And we're looking at about 5,000 to back here about 7,000 feet above radar level. So a distinct, fairly strong and deep rear inflow jet looks to be really giving a lot of momentum to this QLCS as it moves eastward through Mississippi here. And at this point, east of Taylor and going towards Thaxton, Mississippi, you start to see maybe another surge right along the leading edge. You can see it notably in spectrum width here. If I go back and forth over these few scans, you see a distinct change in concavity there along the leading edge of the outflow, which is in these situations often most notable in spectrum width, but you can also see it in velocity imagery there. Also point out really clear area southwest of Denmark here of enhanced spectrum width. It's been ongoing for quite some time, So given that this is coincident with the northern edge of this rear inflow jet that appears to be descending, and also potentially in an area where you could expect some mesovortex genesis, I'd really be watching that very closely. I'm going to zoom out here just a little bit, give broader context to this section of the QLCS now. As I step forward a few more scans, around this time you really start to see more distinct reflectivity dropout here to the east of Oxford. Still have that very nice Boeing signature there. So you see what could be considered an entry point here, UDCZ entry point near Thaxton, go from balanced to the south of Thaxton to more of a shear dominant portion of the line there to the north of Thaxton. So moving forward a little bit more, you're maybe getting some clearer rotation. It's very broad at this point, but a little bit stronger outbounds to the north of Thaxton, stronger inbounds to the west of Thaxton at this point. And this area of inbound seems a little bit distinct from what we're seeing with a broader rear inflow jet at this particular point. So I'd be watching for potential mesovortex genesis here. And, you may have enough evidence at this point to even pull the trigger and go ahead and issue a tornado warning at this particular point, depending on your specific confidence. A brief area of stronger rotation here, stronger couplet north of Thaxton. This is at 2123. And during this time as well, a couple minutes later, you again see a distinct area of reflectivity dropout. So at this point, yeah, starting to get some really nice inbounds northeast of Thaxton. I would say if you have not issued a tornado warning yet, this is the time. You have very clearly tightening and strengthening rotation to the northeast of Thaxton, concentrated area of inbounds here of about 60 knots or so, outbounds increasing pretty rapidly, or about 40 knots. So that would meet the threshold for that strong mesovortex at this time too. Don't really see a concentrated area in spectrum width, a concentrated either elliptical or a circular area of spectrum width, but nonetheless, looks like you have a line break there in KDP as well. So altogether, it looks like this is, if you haven't issued a tornado warning yet, I'd say the threat is imminent at this particular time. So with that in mind, let's say that we do issue a tornado warning. Let's see how things progress. Continue to see that couplet coming into better shape there near a crew. Continues to strengthen in terms of both outbounds and inbounds, coming a little bit better focused with time. Reflectivity dropout has really cut into the QLCS here between the crew and New Albany, west of Blue Springs. Very distinct KDP drop and break in KDP there as well. Starting to see spectrum width become a little bit more circular and defined. At this point, reflectivity, I mean, it's effectively a line break in reflectivity now too. Again, spectrum width becoming more well-defined, very clear line break in KDP, continuing to see a strengthening couplet. This is the best signature probably we've had thus far in spectrum width in terms of that concentrated area of likely rotation. Going to 2140. 2141 have a couple areas of pretty strong rotation here at this point. I'm going to go ahead and turn on LSRs just so we can see how things evolve from here. I'm going to switch over to correlation coefficient as well, see if we can identify any TDSs. A few distinct areas of enhanced inbounds and outbounds. That is a good couplet right there. Outbounds about 55 knots, inbounds 51 knots, gate to gate. Even stronger here. And then we start to finally get some reports coming in, trees downed or snapped. Again, this is a very notable couplet at this particular point. Another one down here to the south by Guntown. That one continues to strengthen with time as well. And at this point as well, look at what you have. You have TDS here. You have another TDS down here. So multiple tornadoes in progress at this particular time. Multiple damaging tornadoes in progress. So although LSRs may not have shown up just yet, there are indeed a couple of tornadoes in progress. So I'm going to just turn off the LSRs actually at this particular point. That debris field widens a little bit, broadens a little bit at this particular time. So maybe brief, those initial tornadoes, but then you get another one here between Baldwin, Guntown, and that one actually, that debris signature broadened very rapidly. So nonetheless, here's the lay of the land at the moment. And this is a good hour and a half after our initial warning decision point. This is about half an hour. Well, those first tornadoes were about 20 minutes after our second point where we were really starting to get concerned about the potential for tornadoes. So there's certainly potential for lead time in some of these events. And I'll just step through here the remainder of the radar imagery that I have. Can you continue to see these areas of couplets as the storm approaches the Alabama-Mississippi state line. Another area with really strong outbounds coming up along the line. It's similar to that previous case in which we saw these surges along the line that sometimes led to mesovortex genesis or tornado genesis in that previous case, and I've seen it in many other cases as well. And this is somewhat of a longer-lived line break type signature, which poses concerns for this cyclic mesovortex genesis and tornado genesis in events that I've seen in the past. And you can see we just continued to get damage. There were several tornadoes as this feature moved into northern Alabama as well. So this was quite a prolific event in terms of tornado production and just general wind damage in what was a marginally unstable environment. So just some takeaways here as we wrap up. First off, severe high shear low CAPE events are typically characterized by strong synoptic scale forcing for ascent, which can facilitate rapid destabilization through either a low-level theta E advection and or the release of potential instability. High shear low CAPE events tend to have fairly complex evolutions as well, often featuring mixed mode scenarios, so you could have supercells and QLCSs coexisting. We didn't talk a whole lot about that in this module, but if you look back at that first case in a little bit more detail, there were some miniature supercells out ahead of the QLCS that merged with the QLCS at times and actually prompted tornado genesis in some circumstances. So you can have those constructive storm interactions and potentially some unique radar signatures as well. And finally, dual polarization radar signatures such as KDP drops can supplement guidance in the existing mesovortex warning system to aid in warning decisions and potentially give you some additional lead time during high shear low CAPE events.